So I will be teaching you physics, and we have already completed mathematical tools. Okay, and while completing mathematical tool, I told you that with the help of mathematical tool we express the mathematical phenomena that is associated with the laws and the law governing the nature, right? So today we will deal a new topic, that is unit and measurement. So you must be wondering while looking at the sky that how everything is so well arranged, how all the things are so well organized, right? So there must be some law which will be governing whole universe. So our physics is nothing but the study of nature and its laws. So if I go by basic definition, then physics, that word came from Greek, that meaning is knowledge of nature, okay, and the field aims to analyze, understand the natural phenomena of the universe. So how simply we can keep the law so that it can make the complex situation understandable, that is the role of physics. And physics uses mathematics as a tool to express itself. So mathematics is the language of physics, you can say. So no matter whatever be the expression you have gone through till now, whether f is equal to ma gm1 m2 upon r square, these all expressions are mathematically expressed. So they are mathematically expressing the natural phenomena. So physics uses maths to express itself. So that's why we call that maths is the language of physics. Okay. In physics, we are dividing different fields. So first one that we will be dealing is mechanics, and after mechanics we will talk about heat and thermodynamics. Then we will be talking about optics, sound, and second year topic electricity, magnetism, and structure of atom. So physics is the foundation of every science. So whether it is chemistry, biology, geology, all boils down to physics, right? And all, whether you take chemistry or geology or botany or any other science, basically they are dealing with the interaction of atoms. So for interaction of atom, we have the last topic that we will be learning in modern physics. So there we will talk about the structure of atom and the new development in physics. So that we will be dealing in the last, right? So how laws get developed? We are talking about the laws. Ki physics is nothing but defining or expressing the laws of nature. So how the development happens? You must have heard the name of famous physicist Newton, right? So what he did? So he concluded that the reason of why apple is falling on the surface of earth is same as the reason why moon revolves around earth. So both reasons are same, and this way he developed gravitational field concept, okay. And what he said ki the reason for moon revolving around earth and the reason why apple is falling on the surface of earth is same, and that both will be governed by this formula g m1 m2 upon r square. So two masses in a space in universe, they will attract each other by this force. So this force explains wide range of phenomena with amazing precision, right? So this simple expression, you look at the simplicity of the expression, two masses, they attract each other by this simple expression. So how simply Newton put the idea of gravitation, and this expression precisely explain very complicated situations, right? Similarly, if I talk about other law, this is Newton's law of gravitation, and if I talk about other law like Coulomb's law, so here this is the interaction of masses. Coulomb's law is the interaction of charges. So if we have two charges in a space, q1 and q2, separation r, then same way, the way we have gravitation, law of gravitation, here we have constant 1 upon 4 pi epsilon naught q1 q2 divided by r square. So Coulomb observed the interaction between two charges and he formulated this one, F is equal to k q1 q2 upon r square, where k is 1 upon 4 pi epsilon naught, right. Look at the similarity, here charges, here masses, divide by separation square, divide by separation square. So two masses m1 m2 separated by distance r, and the force of attraction here is given by this formula. So similarly we have other laws, and those all laws are based on the observation. Okay, so first we observe the thing and we try to formulate what is happening, and with the help of that we can predict what can be the possible outcome of a particular event, right. So with the help of pre-existing laws we can tell that this is going to happen if this happens, right. So these law also help us to predict what may happen in future, right. So this is the way whole development happens, observation and formulation, and then we cross check all the theories for under different circumstances, and if we find everything is correct and true for every situation, then it becomes law, like we have law here and law here, right. So this is what physics is all about. So these are the topic we are going to learn. So first our focus will be on mechanics, that is Newtonian mechanics. So Newton's 3 law and the law of gravitation we will be using here, and with the help of that we will be talking about what happens in the solid state, gaseous state and the liquid states, right. So you must have seen I just wrote two laws, one is Newton's law and another is Coulomb's law. Both are dealing with the forces, right. So there are four fundamental forces in nature. First one is gravitational force, second one is electromagnetic force, third one is strong nuclear force, and fourth one is weak nuclear force. So gravitational force is the first fundamental force, electromagnetic force, strong nuclear and weak nuclear. So apart from these four fundamental forces we don't have any other type of force. You might be wondering like what is friction, what is normal reaction. Friction, normal reaction come under this category, electromagnetic force, right. So when two bodies are in contact, the molecule of one body start exerting force on molecule on other body, and that force we call normal reaction and friction, right. So this we will talk later, but for time being these are the fundamental forces. There is no other force which will be in the list of fundamental forces. Okay, so one by one we will talk about all. Let's see. So gravitational force, as you know, you must have learned in your 9th standard, G m1 m2 upon r square. Two masses attract each other and force of attraction is given by G m1 m2 upon r square. The force of attraction between two bodies in universe raised due to their mass is called gravitational force. It is a universal force, that is the object on earth experience force due to gravity of earth. Similarly, satellite revolving around earth and other planet revolve around sun, these all the motions are governed by this gravitational force. Okay. So I hope gravitational force is clear and you must be knowing it before. Then next comes electromagnetic force. Earlier people used to think that electrostatic field concept is different and magnetic field concept is different. Later they realize that they are inseparable, like they are created by, whether we have electric field or magnetic field, they are created by the motion of charge. So they are inseparable, right. So the force of attraction or repulsion between charges, okay, is called electromagnetic force. So Coulomb's law we have just discussed, 1/4 pi epsilon naught q1 q2 divided by r square, right. So that is force of attraction or repulsion depending on whether we have both the charges positive, both the charges negative, or one positive, one negative. Now if the charges are in motion, then they produce magnetic field. So stationary charge produces electric field, while moving charge produces electric as well as magnetic field, right. How that we will discuss later, but here we are just talking about the forces, the type of forces we have. Similarly, the magnetic field exerts a force on the charged particle. Okay, so electric field exerts force due to electric field, charged particle experiences force. Similarly, due to magnetic field, a moving charged particle experiences force, and therefore the name is electromagnetic force. This force is much stronger than the gravitational force. Okay, in comparison, if you see, so electromagnetic force is much stronger as compared to gravitational force. But the problem is, like, we generally like earth is moving around sun or moon is revolving around earth, these motions are governed by gravitational force, because if you take object as a whole, so it is electrically neutral. So electromagnetic force does not come into picture unless until body is having charge. So most of the time we will be talking about gravitational force. Right now I am standing on the surface of earth, that is because of this gravitational force, right. So I can feel the gravitational force right now, though it is much weaker as compared to electromagnetic force, right. But the net charge on the matter is 0 and hence the matter is electrically neutral. So on my body there is no charge, on earth there is no charge, so we are bound by gravitational force. If earth is carrying charge, net charge, and my body is carrying net charge, then I will be experiencing the electrostatic force, which might be very large as compared to the gravitational force, right. But the net charge on the matter is 0 and hence the matter is electrically neutral. Therefore the electric force is 0 and hence gravitational force dominates. So comparison is clear. Electromagnetic force is far large as compared to the magnetic as compared to gravitational force, right. So gravitational over electromagnetic over. Now nuclear force. So inside nuclear there will be proton, neutrons, and proton will be exerting force on each other due to Coulombian repulsion. So proton both are positively charged and they try to fly apart, but as the nucleus is stable, there must exist a force which will be counterbalancing the Coulombian repulsion. So proton which are experiencing repulsive force due to their charges, they are not flying apart, nucleus is stable, that means there has to be some force which will be counterbalancing this repulsive force. So inside nucleus, among nucleon, there exists one more type of force, that is called nuclear force, and that is very strong, and that is binding the nucleon in the nucleus. So nuclear force will be between proton neutron, and it is attractive in nature. Obviously it has to bind the nucleus, it has to counterbalance the electrostatic repulsive force. So you can read here, the force that binds the proton neutron in the nucleus is called the strong nuclear force. Everybody knows that like charges repel each other. It means that the proton must be repelling each other with a strong electromagnetic force, and to bind, so this is what I told, to bind proton together in a very small space, the strong nuclear force must be stronger than the electromagnetic force, and thus the strong nuclear force dominates the strong electromagnetic force. That means nuclear force is stronger than the electromagnetic force. Electromagnetic force is stronger than gravitational force, but nuclear force is stronger than electromagnetic force. Okay. Studies showed that the strong nuclear force is strongest force in the nature, and it is about 100 times the electromagnetic force. So it is that strong that it will be 100 times stronger than electromagnetic force. It is the force responsible for the stability of the nucleus, as I told you earlier. Strong nuclear force exists only in the nucleus. Okay, so right now if nucleons are outside, assume that right now nucleons are outside the nucleus, then they won't be experiencing nuclear force. So nuclear force is short range force only come into picture when the separation is very small. So when they are inside the nucleus, then only this force will come into picture. While we have seen electromagnetic force, Coulomb's force and gravitational force, they are long range forces, right. Hence the electron did not experience this force. Electron does not experience this force because they are outside the nucleus. Okay. Recent studies have found that the proton and neutrons are formed from the much smaller constituent called quarks. Okay. So they are proton and neutron, they are further made up of particle called quarks. So these all points we will see in the modern physics. Right now I hope this comparison is clear ki strong nuclear force is the strongest among all 4 fundamental forces, and next we have weak nuclear forces. Okay. So what are weak nuclear forces? So some forces get developed inside the nucleus during beta decay or during transition, then those forces are called weak nuclear forces. They are weak as compared to all the forces what we have seen. Okay. So we all know that the gravitational force exists everywhere, electromagnetic force exists between charges, and the nuclear force exists within the nucleus. In contrast to these forces, the weak nuclear force exists only in certain nuclear processes like beta decay. In this process the nucleus emit an electron, and so this is about the process and later we will learn. So nucleus emit an electron and a neutral particle called neutrino. The weak nuclear force is the weaker than the strong nuclear forces and the electromagnetic forces, but it is stronger than the gravitational force, and so it is stronger than gravitational force, and the range of influence of this force is very small. Look at this order, 10 to the power minus 6 minus 16 meter. So very small distance it will act. If distance is large, then it will disappear, but the value of the force will be greater than gravitation, less than strong nuclear and electromagnetic force. Okay. So these are the 4 fundamental forces we have. There is no other force apart from these forces. This you have to keep in mind. Now along with these fundamental forces that we are going to study, we will also study some laws like law of conservation of energy, conservation of linear momentum, conservation of angular momentum, right, these laws. Okay. So right now I am not getting into detail ki how we have law of conservation of energy, law of conservation of momentum and all, but I am just giving you information that we are going to learn all these laws later. So what are the laws? Conservation law, also called law of conservation in physics, serve several principles that state that a certain physical properties of that physical property, in this case is energy, and here it is linear momentum, and here it is angular momentum, and here it is mass. So these physical property, they does not change, that is why we say that they remain conserved. So in an isolated system, isolated physical system, where system is not interacting with any other system, the energy of the system remains conserved. We say that energy can neither be created nor be destroyed, because for whole system there will be interaction, energy may get converted into one form to other form, but the total energy will remain constant. Similarly, linear momentum, if there is no external force acting on the system, we say that the linear momentum of system is constant. Here I can give you just one information. According to Newton's law, force is equal to rate of change of linear momentum. So don't worry about what I am writing here, d and d. Okay, those who haven't attended the class of mathematical tool, they won't be understanding this what I am writing here. This is called differentiation. Okay, so I suggest you to go through all those classes what I have taken for mathematical tool. Now, so force, according to Newton's second law, force is rate of change of linear momentum. If there is no force acting on the system, that means rate of change has to be 0, and that means momentum has to be constant. So in this situation, momentum is not changing with time. So momentum is invariable in this case, and for these cases I can say linear momentum of the system will remain conserved. Similarly here, so I hope you understood this part. Even if you are not understanding, this we will discuss again when we will be talking about Newtonian mechanics. For time being, what is the meaning of conservation, that I am explaining. That a particular physical quantity remains constant is called conservation. Similarly, conservation of angular momentum, same equation I can write this way: tau is equal to dl by dt. This is torque and this is angular momentum. If on the system there is no external torque, then we can say angular momentum is conserved, angular momentum is constant. So angular momentum is constant, angular momentum is conserved, and in that situation you can apply concept of conservation of angular momentum. Similarly, conservation of mass. So as long as no nuclear reaction is involved, we can say that mass remains conserved. But once we talk about the nuclear reaction, we have seen that smallest change in the mass creates a big energy, and so this will have very limited use. Later we will talk when not to conserve the mass. Okay, whenever we have nuclear reaction, then some part of the mass gets converted into energy according to Einstein's equation, E is equal to mc square, right. So all this we will discuss in modern physics. Now let's move to next one. So I hope up to this one everything is clear. So for 4 fundamental forces and then some law of conservation of physical quantity, particular physical quantity under given circumstances. Now let's get back to our main topic, that is measurement and unit. What is measurement? What do we mean by measurement? So if I give you say this remote and I ask what is the length of this remote, so how you will measure the length of this remote? You will get a meter stick and place beside this remote, and you will see which mark is coinciding with these two ends, and by that you can find out the length of this remote. So you are measuring the length of remote using what? You are measuring the length of remote with the help of comparison. So you are comparing the length of remote with the length of meter scale, and by that you are telling the length of the remote. So measurement is nothing but comparison. So similarly, if you go to market and you ask for say 1 kg potato, and that vendor keep 1 kg potato on one side and potato on one side, and other side he will put some weight, and when that weighing machine needle will be exactly at middle, then you will understand that this much potato will be equal to this much mass, right, 1 kg or 2 kg or 3 kg. So again, that is comparison. So measurement is nothing but comparison, right. So similarly, if I ask for what duration this class will go, or today how many hour you studied, so you compare that with clock or stopwatch, so that is again a comparison. So measurement is comparison, but comparison with what? So while measuring the length of this remote, you took meter scale, okay. So you don't do this ki okay, this is coming up to this length, because this is not a standard, okay. I cannot say ki this is this much big. So best way I can express the length is, I'll tell that this is say 20 centimeter or 30 centimeter, whatever it is coming, right. So we compare length, time, mass with some standard, and that standard is called unit. So measurement is comparison with some standard which we are calling unit, okay. So I hope meaning of measurement is clear. Now let's talk about units. So what are unit? Units are a standard, just now I told. So here you can see we have stopwatch, we have weighing machine, and we have meter scale. With the help of that we can measure length, okay, inchy tape. So these are all our measuring instruments, and they are standard. You cannot have 1 meter scale where marking is like this and other meter scale where marking are little far. So all the scales of 1 meter length will have exactly same marking. Similarly, 2 kg potato on this weighing machine and 2 kg potato on other weighing machine, they will weigh the same. And same thing happens here. Duration of event, if you want to measure with a stopwatch, then 2 events of same duration, you are going to get the same time. So we have standard instrument, with the help of that we compare and we measure. So we are comparing with the standard, and that standard we are calling unit. So unit of time, time we measure in second, okay. Similarly, unit of length meter, and unit of mass kilogram. So these are the unit of physical quantity time, physical quantity length, physical quantity mass. So different physical quantities will have different unit of measurement, okay. So you can read the definition. All physical quantities are measured with respect to a standard magnitude of the same physical quantity, and these standards are called unit, okay. So जो standards हैं उसको हम unit बोलते हैं. Now let's move to next slide. What quality in unit will make them standard, okay. So what is the requirement? You can say basic properties of unit. So what are the requirements? So first is they must be well defined. Meaning of well defined I'll tell later, okay. So this is first thing, well defined. What is the meaning of well defined? I'll tell later. Look at the second one, they should be easily available and reproducible. So if I ask ki bhai measure the length of this remote, and you will say ki take my hand as standard, okay. So your hand, if I consider standard, so if I want to measure this length of remote or something else somewhere else, or some other person want to measure the length of something in some other place, then your hand cannot be easily available everywhere. And visualize the situation, if someone in America want to measure the length and he cannot measure the length with the help of your hand, So you cannot define this part of your hand as a standard to measure the length. So it is not easily available everywhere and not reproducible. Okay, so the unit should have this property that it is easily available and reproducible. So standard what we are taking, we can easily reproduce everywhere. Okay, and the next one, they should be invariable. So your hand is not qualifying for the unit or standard, because as you grow your hand length will change. So it is invariable, sorry, it is variable, and the requirement is it has to be invariable. So whatever we are saying or whatever standard we have today, tomorrow also the same thing. Okay, if it changes, it does not qualify for being a standard. So it has to be invariable. Now the last one, they should be accepted to all. So this is the another thing, right? So something, if you want to define as standard, some people are accepting it, other people are not accepting it. So it cannot be a standard, right? Because everyone is following their own measuring system. So it must be accepted to all, right? So these are the 4 quality a standard should have, a unit should have. Well defined, I'll tell later. So I hope you understood what is unit and what are the requirements for something to be called unit. Now let's first talk about the fundamental quantities. So physical quantities like length, mass, time. Okay, these are the physical quantity. Pressure, force, momentum, these all are physical quantities. Out of all these physical quantities, some physical quantities don't have relation with each other. Okay, they are independent with each other. So for example, length and time, they are independent of each other. Okay, so length you measure by scale and time you measure by clock. But if I ask speed or velocity, so speed or velocity can be measured with the help of length and time. So velocity or speed is derived physical quantity, and length and time, they are independent physical quantity, or you can say fundamental physical quantity. So there are 7 such fundamental physical quantity which don't depend on each other, right? You cannot express mass in terms of length. Similarly, you cannot express length in terms of temperature. If I ask what is the length of this remote, then you cannot say 32 degree centigrade or 32 Kelvin. Okay, so you cannot express length in terms of temperature. Similarly, current, luminous intensity and amount of substance, these all are independent of each other and they are called fundamental physical quantities. So we have got 7 fundamental physical quantities which cannot be expressed in terms of each other. So let's see them all. The set of physical quantities which are completely independent of each other, completely independent of each other, are called fundamental physical quantities. Okay. Now let's start with mass. So here I have written SI units, and notation. This notation we will talk about later, right? Let's first see this part. So mass we express in kilograms, CGS, centimeter gram per second, in that gram will be written. Similarly, length in meter, CGS it will be centimeter. Time is measured in second, so unit will be second, and in CGS also it is second. Then temperature in Kelvin, and in CGS it is in degree centigrade. Similarly, current is ampere, measured in ampere, represented by A. Luminous intensity, candela, okay, and here we don't have CGS unit for that. And then amount of substance, mole, again we don't have any CGS unit for that, right? So these are the 7 physical quantities which are in the set of fundamental quantities. Other quantities can be derived with the help of these quantities. So how to derive other quantity with in terms of these quantity, that we will see later. Let's first see this. What's the meaning of well defined? Okay. So what is the meaning of well defined? What's the meaning of kilogram being well defined, or meter being well defined, or second being well defined? So let's see how 1 meter is defined. How 1 meter is defined. The path travelled by light in vacuum during time interval of 1 divided by this value. Okay, the path travelled by light in vacuum during the time interval of these many seconds, okay, is 1 meter. So now it is well defined, I feel, right? So you are defining this 1 meter in terms of speed of light. So now this is well defined. Anywhere you can use this definition to define 1 meter. Okay, so now it is well defined. This is the way we are defining 1 meter. Kilogram. So the weight you are using, okay, 1 kg weight. So how we decide whether this is 1 kg or not? So for that, first we need to define 1 kg. How 1 kg is defined? A cylinder of platinum iridium alloy maintained under vacuum condition by International Bureau of Weights and Measure in Paris. So in Paris, you can see here a small cylinder is kept under vacuum condition so that there won't be any erosion. So in vacuum condition it is kept. The weight of this is defined as 1 kg. So now it is well defined. A replica of this one is produced and it will be sent to different places so that their replica can be produced and it is easily available everywhere. So well defined, easily available, right, and accepted by all. So everyone accept this 1 kg. Now as we are using this platinum iridium alloy, it is very heavy, its density is very large. So for 1 kg size, for 1 kg mass, the size is very small. Look at this value, 36.2 millimeter. You can see here this cylinder size is very small. The weight you are using for 1 kg, that is very big, okay, because that is made up of iron. So this is made up of platinum iridium alloy. Size is very small, okay. So I hope this is clear. So 1 meter is clear, 1 kg is clear. Now how we define 1 second? So for 1 second, here it is written World's first atomic clock, and that is 1955. Okay, how 1 second is defined? The duration, period of radiation corresponding to transition between two hyperfine levels of the ground state of cesium 136 atom. So I hope you are unable to understand what is written here, because right now you don't have any idea about hyperfine levels and the ground state. Okay, so just one information, then when electron jumps from higher energy level to lower energy level, then it radiates energy, right? So hydrogen atom, if we have electron, if we provide some energy, it goes to higher energy level, and while returning back it radiates some amount of energy. Okay, so it is something related to that, and you don't have to remember all these values. I am just telling you what's the meaning of well defined. So that's why I am giving you all information. Otherwise this information will never be asked in the exam. So duration of this period of the radiation corresponding to the transition between the two hyperfine levels of the ground state of the cesium. So we are well defining what is 1 second is for a particular cesium 133 atom, this situation, then it is 1 second. Okay, and this is the definition of atomic clock also. More than 200 atomic clocks are located in the Metrology Institute of Observatories in more than 30 countries around the world. So different places in the world we have atomic clocks. and we can adjust the time, and these times what we have in the clock, they are adjusted according to this one. So even in satellites the clock will be matched with this time, so that standard is being followed everywhere. Okay. Now ampere, what is 1 ampere? 1 ampere current. So obviously again we have to define. So how it is already defined. So look at this, the constant current if maintained in two straight parallel conductor. So first you need to understand that if one conductor is there, another conductor is there, and these two are carrying current, then what happens, they start attracting each other or repelling each other depending on the direction of current. Okay. So two wires carrying current, they attract each other or repel each other. Now so you can see one wire here, another wire here. If they are kept at a particular separation, 1 meter separation, and they are experiencing this much force, then they are carrying 1 ampere current. So if two wires are kept at 1 meter separation and they are experiencing this much force per meter of length, then at that time the current they carry will be 1 meter. So it is again a well defined. Now let's move to next one, Kelvin. Temperature will be measured in Kelvin. Okay, and how a Kelvin is defined? So the unit of thermodynamic temperature is the fraction 1 divided by 273.11 of thermodynamic temperature of triple point of the water. So what is triple point of the water? Where all three states of water coexist. So look at this diagram. So you can see here we have ice state, water state and the vapor state. All three states coexist here. So for that we have a standard pressure and we have a standard temperature, right? 0.01 is written here. So that particular temperature is defined as 1 Kelvin. So 273.16 is 0.098 degree centigrade, and the room temperature, other information is given. Room temperature, which is generally 72 degree Fahrenheit, is 295.5 Kelvin. And one more information we never write, like 273 Kelvin should be written this way. We don't put degree here. Fahrenheit and centigrade we are putting degree, but here we don't put degree, right? So this is the way 1 Kelvin is defined. Now let's see next one. Amount of substance, mole. Okay, so how 1 mole is defined? So if you take carbon 12 and this much mass you take of carbon 12, then that will be 1 mole of carbon. Okay, the mole is the amount of substance of a system which contain as many elementary entities as there are atoms in 0.012 kilogram of carbon 12. Now, so 1 mole contains these many entities. So 1 mole of electron, 1 mole of atom, 1 mole of molecules, right? So these many entities will be there. So if I say how many atoms will be there in 1 mole, so 6.023 into 10 to the power 23, this is called Avogadro number. Okay, and entities must be specified and may be atom, molecule, ion, electron or other particles or specified group of such particle, right? So mole is also clear. Now last one, candela, luminous intensity. We won't be requiring this, but for definition I am telling you what is 1 candela. So luminous intensity in a given direction of a source that emits monochromatic radiation of frequency this particular frequency radiation, if having intensity 1 divided by 683 watt per steradian, then that is called 1 candela. Okay, so candela we won't be using it, okay, in 11th and 12th. So but this is the definition, right? Now apart from these fundamental, we have got two supplementary units. So one is plane angle, another is solid angle. Look at the previous one. Here steradian is written. Steradian. Okay. So that's why I am explaining what is steradian. So plane angle you must have used the definition of angle, arc by arc length divided by radius. So arc length L divided by radius, this is L by R. Okay. And solid angle. How solid angle is defined? So here I took arc and I joined these points to the center. This angle was plane angle. Okay, and if I take a sphere, a big sphere, and cut it, so this would have been the shape. I hope now it is clear. So I'll cut it this way. And I join all the point on the periphery to the center of sphere. Center of sphere will be somewhere here. I join all these points. So here we define solid angle as area divided by r square. So here it is length by r, while in this case this area divided by r square, where r is this distance, and the area I am talking about is this area. So total area, surface area divided by r square will give you solid angle. So here if you just complete this arc, you will get circle, and the angle subtended by circle at center, if you want to find out, then arc length will be 2 pi r and the radius is r. You can see the angle subtended at center is coming 2 pi. Look at this one. Here if I complete it, if I complete this sphere and I ask how much is the angle subtended by the whole sphere, then surface area of the sphere will be 4 pi r square divided by r square. This will get cancelled out and here we are getting 4 pi. So angle subtended by the sphere at the center is 4 pi steradian, while the angle subtended by the whole circle at the center is 2 pi radian. Okay, so in 3 dimension what is happening? We have solid angle, and over a plane what we have is a plane angle. So this part is clear, right? So 2 supplementary units and 7 fundamental, and now let's talk about derived. Before that let's talk about the unit set. Now, so these are the unit sets. So first one is FPS, foot pound second system. So unit of length foot, okay, here it is written foot, mass pound, and time second. So foot pound second. right? Another system, CGS system. So length centimeter, mass gram, time second. Okay. So CGS system, length will be in centimeter, mass will be in gram, and this will be in second. This is another system. This is one system, foot pound second, centimeter, gram second, and most popular that we will be using MKS system. Length will be in meter, mass will be in kilogram, and time will be in second. Okay. And the last one is international system of unit. So this we will see later. Okay. So these are the unit set. Now derive physical quantity, as I told you, like velocity you can calculate using length and using time. So length and time, they are fundamental, and with the help of length and time we can measure velocity. So the physical quantities, you can see the physical quantities that depends on other physical quantities. Okay. So physical quantity that depends on other physical quantity, actually these other physical quantities are fundamental quantities. For its measurement are known as derived quantities. Okay. The measurement of derived quantities directly depends upon the measurement of derived physical quantities directly depends on other quantities. So in order to measure the derived quantity, one must measure the quantities that depends upon. So what does that mean? To measure velocity, you can see here, to measure velocity you have to measure length and you have to measure time. So in terms of measurement of length and time we can write velocity. Okay. Except 7 fundamental quantities, all other quantities are derived physical quantities. Okay. So velocity, as I already told you, unit of velocity, unit of distance, unit of time, unit of distance meter, and unit of time is second. So unit of velocity will become meter per second. Now look at these quantities. Volume, if I take cube, by measuring length I can measure the volume L cube. So volume is L cube. So if L is measured in meter, then the unit of volume will become meter cube. Okay, unit will become meter cube. You can also express this in centimeter cube, or you can also express this in liter. Right. So 1 liter or a liter is 0.01 meter cube and 1000 centimeter cube. Similarly, force, F is equal to ma, right? Force F is equal to mass into acceleration. So if you know unit of velocity meter per second, what is the unit of acceleration? Let's first calculate acceleration. So acceleration is unit of acceleration. Unit of acceleration is unit of velocity divided by unit of time. By acceleration is velocity by time. I can write it this way. And unit of velocity I can substitute from here, meter per second. So here if I write meter per second and this I will write second, then this can be written meter per second square. So that I can use here. So mass is in kg, unit of mass is kg, unit of acceleration meter per second square. So force we are getting kg meter per second square. So kg meter per second square, and SI unit, that is Newton. You can also measure it in dyne, that is CGS unit, okay, and it is gram centimeter per second square. So kg gets converted into gram, meter gets converted into centimeter, and second remains second, that is CGS unit. Now comes pressure. So if you have force, with the help of force we can write unit of pressure. So pressure is force per unit area, right? Force you are getting kg meter per second square. So this is kg meter per second square into area, that is meter square. So if you simplify, then meter is getting cancelled out, kg meter inverse second to the power minus 2. Look at this one, meter getting cancelled out, meter will go up, power minus 1, second power minus 2. So this I can also write this way, kg meter inverse second to the power minus 2, okay. Or you can use the basic definition of this one, Newton per meter square. So Newton per meter square, that is also called Pascal. So SI unit is Pascal, okay. Now last one is energy and work. So energy or work, any expression related to the work or energy, if you remember, you can get the unit. So any expression like kinetic energy expression half mv square or work done expression. So I'll erase everything. So energy and work, force into displacement, I am not writing a proper formula F vector dot ds vector, because here we are concerned about the unit, right. But this is not the way work is written, later you will come to know after we discuss vectors, okay. So work is force dot displacement just for unit. So force, this is Newton, displacement meter. So work can be written Newton meter, one is Newton meter, and SI unit is joule, okay, we express in joule. And MKS if you want to write, then Newton is kg meter per second square into another meter. So meter square second power minus 2, okay. So kg meter square divided by second square, you can see here. So these all are derived physical quantity and their units we are getting with the help of fundamental units, okay. Let's see one more set. So look at all these: plane angle, solid angle, frequency, force, pressure, energy, power, electric charge. So up to here we will deal in 11, and beyond this one we will deal in 12th standard. So the charge, and look at this one: electric potential, capacitance, resistance, conductance, magnetic flux density, inductance, Celsius, temperature, luminous flux, all this up to here. Inductance we will use in 12th standard. So now let's see this one. Plane angle, just now I told it is radian, okay. Solid angle, it is steradian, right. Frequency is 1 upon time period. So any unit you want to find out, you need to remember the formula associated with it. So frequency is equal to 1 upon time period. So second inverse, I can see second inverse force Newton, just now we have discussed, and it is kg meter per second square, this we have seen. Pressure, Newton per meter square, or Pascal, Newton per meter square, and Newton is kg meter per second square into, divided by meter square. Okay, so 1 meter will get cancelled out, meter to the power minus 1. I hope you are understanding the calculation. So simple expressions are there. Energy work we have just seen, that is joule. Force into displacement, right? For work, force into displacement. So Newton meter also we can write, and Newton if we convert from here, then kg meter per second square into meter. So kg meter square second to the power minus 2. And power, last one, power radiated. So power radiated, what is the basic formula of power? Power is rate of doing work. Okay, so actually we write it this way, P is equal to dW by dt. This is differentiation of work with respect to time. Okay, now for unit I am just writing it this way, power is equal to W by T I am writing. So power is equal to W by T. If we write, then W is work. Okay, this is work, and work unit we already have. Where? Here. So either you can directly say work by time, that is joule per second, or you can substitute the value and you can get the unit in MKS form. So work is kg meter square divided by second square into second. So kg meter square second to the power minus 3. Look at this. So this is giving me power. Okay, and now electric charge, the last one. So current is rate of flow of charge, and current is the fundamental. So current is dq by dt. So for unit I will write I is equal to q by t, only for unit. Okay, so q is equal to I into t. I is in ampere, right? So this is ampere and this is second. So q is equal to ampere second. So unit of charge is ampere second. Here it is written. So today we have completed what are the fundamental forces, law of conservation, and then what is measurement, what are the units. So in next class we will be talking about dimension and dimensional analysis. So I hope you enjoyed today's class. Thanks very much for watching.